Infrastructure as code, IaC, is a key DevOps practice that involves managing and provisioning computing infrastructure through machine readable definition files rather than physical hardware configuration or interactive configuration tools. This approach allows for consistent and repeatable infrastructure deployment, reducing the risk of human error and increasing efficiency. IaC is essential for modern cloud environments where infrastructure needs to be scalable, flexible, and easily reproducible. Traditionally, infrastructure management was a manual process involving physical hardware setup and configuration. This method was time-consuming, error-prone, and difficult to scale. With the advent of virtualization and cloud computing, infrastructure management evolved to include automated provisioning and configuration. IaC represents the latest evolution, enabling infrastructure to be defined and managed through code, bringing software development practices to infrastructure management. IaC offers numerous benefits, including consistency, repeatability, and version control. By defining infrastructure as code, teams can ensure that environments are identical, reducing the "it works on my machine" problem. IaC also allows for versioning of infrastructure configurations, enabling rollbacks and tracking changes over time. Additionally, IaC facilitates automation, reducing manual intervention and speeding up deployment processes. IaC revolves around several key concepts: declarative versus imperative approaches, idempotency, and immutability. Declarative IaC specifies the desired state of the infrastructure, while imperative IaC outlines the steps to achieve that state. Idempotency ensures that applying the same configuration multiple times results in the same state, preventing drift. Immutability involves replacing rather than modifying resources, ensuring consistency and reliability. Several tools are popular in the IaC space, each with its strengths and use cases. Terraform, by HashiCorp, is known for its cloud-agnostic approach and extensive provider support. AWS CloudFormation is tailored for AWS environments, offering deep integration with AWS services. Azure Resource Manager, ARM, templates are designed for Azure, providing native support for Azure resources. Other notable tools include Ansible, Chef, and Puppet, which focus on configuration management. Terraform is a widely used IaC tool that allows for the provisioning of infrastructure across multiple cloud providers. It uses a declarative language called HashiCorp Configuration Language, HCL, to define infrastructure. Terraform's state management feature tracks the state of the infrastructure, enabling incremental changes and ensuring consistency. Its modular approach allows for reusable and composable infrastructure components, promoting best practices and maintainability. AWS CloudFormation is a service that provides a common language for describing and provisioning AWS infrastructure resources. It uses JSON or YAML templates to define resources and their dependencies. CloudFormation's stack management feature allows for the grouping of resources, enabling easier management and updates. With CloudFormation, users can leverage AWS-specific features and integrations, making it a powerful tool for AWS-centric environments. ARM templates are JSON files that define the infrastructure and configuration for Azure resources. They enable the deployment, management, and monitoring of resources as a group. ARM templates support declarative syntax, allowing users to specify the desired state of the infrastructure. They also integrate with Azure DevOps, enabling automated deployment and continuous integration, continuous deployment, CI/CD pipelines. ARM templates are essential for managing complex Azure environments. Ansible is an open-source tool that automates software provisioning, configuration management, and application deployment. It uses a simple, human-readable language called YAML to define automation tasks. Ansible's agentless architecture simplifies management, as it does not require any software to be installed on the target machines. Its extensive module library supports a wide range of tasks, making it a versatile tool for managing infrastructure and applications. Chef and Puppet are two other popular configuration management tools. Chef uses a Ruby-based DSL to define infrastructure as code, focusing on flexibility and customization. Puppet, on the other hand, uses a declarative language and emphasizes idempotency and consistency. Both tools support a wide range of platforms and integrate with various DevOps tools, making them suitable for diverse environments. They help automate repetitive tasks, ensuring consistent and reliable infrastructure management. Integrating IaC into CI/CD pipelines is crucial for achieving continuous delivery and deployment. By incorporating IaC, teams can automate the provisioning and configuration of infrastructure as part of the pipeline, ensuring that environments are consistent and up to date. This integration allows for automated testing and validation of infrastructure changes, reducing the risk of errors and improving deployment speed. Tools like Terraform, CloudFormation, and ARM templates can be integrated with CI/CD tools like Jenkins, Azure DevOps, and GitLab CI. To maximize the benefits of IaC, several best practices should be followed. Version control is essential for tracking changes and enabling collaboration. Modularization promotes reusability and maintainability of code. Automated testing and validation ensure that infrastructure changes do not introduce errors. Documentation is crucial for understanding and maintaining IaC code. Finally, security should be a priority, with sensitive information managed securely and access controls enforced. While IaC offers many benefits, it also presents challenges. Managing state and preventing drift can be complex, especially in large environments. Ensuring security and compliance requires careful planning and implementation. Teams must also consider the learning curve associated with IaC tools and practices. Despite these challenges, the advantages of IaC make it a valuable practice for modern infrastructure management. The future of IaC is promising. With ongoing advancements in tools and practices, the rise of containerization and serverless computing is driving new approaches to infrastructure management. Tools are becoming more integrated and user-friendly, reducing the learning curve and increasing adoption. As organizations continue to embrace DevOps and cloud-native practices, IaC will play an increasingly important role in enabling scalable, reliable, and efficient infrastructure management. Infrastructure as code is a transformative practice that brings software development principles to infrastructure management. By defining infrastructure through code, teams can achieve consistency, repeatability, and automation, leading to more efficient and reliable deployments. While IaC presents challenges, its benefits make it an essential practice for modern DevOps and cloud environments. As the landscape continues to evolve, IaC will remain a cornerstone of effective infrastructure management.